Could you give our listeners a quick rundown of your journey in the field of application security and APIs, and what you've been up to in your careers?
Thank you for having me. It's good to be here. Good to be chatting. Always really enjoy talking about application security, and particularly API security. Very long and a fairly unusual journey, but not an atypical journey for software security people. I don't think people set out to become application security or software security specialists. They sort of stumble into that role, and that's very true of me. I'm a builder. I like building things. I started off as a hardware designer, building hardware, circuit boards, dabbled into cryptography, got hired into a crypto company, did lots of security. So building cryptography devices, PKI accelerators, and various bits of hardware magic, lots of secure modems and secure fax machines and all of that. So kind of had this security aspect to many of the roles that I've had, and it wasn't something that I really focused on. And then, almost by accident, probably about a decade and a half ago, I had a colleague who took a role at one of the banks in London, and just out of the blue messaged me and said, "I'm looking for somebody who can talk to developers and know security. Are you interested?" And I thought, well, that looks interesting. That's something new. So I went and did that, built up a really, really large scale application security program. When you're talking 25,000 developers, 5,000 applications. It's a really massive, massive scale. And I think that's when I really got an appreciation of the enormity of the challenge that our industry is faced in terms of securing software. The problem is bigger than we estimate. I think we sometimes don't appreciate quite how much software is being written and already has been written, right? And these really pose challenges. And I think if we flip that forward to API security, I think the problem is potentially even more significant, simply because of the fact that the numbers of APIs are growing exponentially as systems expand and grow, as we see AI powering systems that are interconnected. The number of APIs is only going to increase. So that's how I've come to be where I am. And then the finer details of the last 15 years. Did uh, building a program, did that for a while. Went over onto the vendor side, had a great stint at Veracode, the static analysis people, and that's really where I first got to be pushed towards public speaking and engaging with people and sharing my ideas. And this is quite a transformative period in my life. I think I'm naturally quite a shy person, and public speaking, that wasn't something that came naturally to me at all. I used to remember going back to my school days, I would avoid any kind of oral presentation or anything that I had to do. I would mysteriously be sick on those days, and I would avoid any occasion where I had to stand up and talk in front of people, which is kind of ironic because that's one of the things that I like most about my career now and where it's taken me. Yeah, so Veracode pushed me into kind of sharing my journey and sharing the lessons that I'd learned in building this AppSec program. And I think always sharing that knowledge is something that I think is very important to share that knowledge. So I did that with Veracode for a while. Did a lot of consulting, various bits and pieces of consulting and advisory work. Went into what, again, on the vendor side. Joined my friends at 42 Crunch. I recently just parted ways with them. I really had a good time, and that's where I really got to get close to API security and get really hands on, and understand the finer details of the challenge of the API security, which are pretty different. And I know we'll talk about this in a bit. Are quite different to application security. They're the same, but they also distinctly different. And the challenges are different. Again, same kind of role talking about this, and then out of the blue, well, one of the first things that happened is I got lucky, and I was asked to curate the 42 Crunch API security pentesters.io newsletter, which is a bi-weekly newsletter. I'm actually just literally before I'm coming on to speak to you, I've just published issue number 246. We've got 6 different articles in there. It's all API security goodness, and it ranges from thought pieces from industry leaders through to tool reviews. We had a really good one this week. We've got some new tools. We've got a deliberately vulnerable API app for those learning APIs, and we've got an article on a new API client. If people are wanting to read more, free subscription. It tends to be very it's vendor neutral, although we sponsored by 42 Crunch, kind enough to sponsor that. It doesn't focus on vendor propaganda too much. It's really a good tool for practitioners and a very popular newsletter. And I think just closing out my journey and where it's taken me now, this is where I came to be involved with Packt Publishing. I was approached by them who commissioned me to write a book specifically on defending APIs. So that's the blue team or the defender view on API security, which is just two. What are we now? We May, so 3 months ago has gone live. And all very exciting to see that finally happen. So that's where I've got to now, and what I'm doing at the moment is various pieces of consulting. I've also founded a startup with my wife, hopefully building a mobile application or a couple of mobile applications to help victims of domestic abuse. And we've got a lot of good ideas around that. And obviously, that is all going to be very API centric.
How does the API security landscape look with the rapid advancements in technological transformations, especially with AI?
This is an interesting one for me. I think there's the way I usually frame these conversations, because I think there's two sides to the story. It's the pessimist versus optimist view. I like to frame it according to that. I think if I'm pessimistic, I have concerns for the general future of software systems. I think, for example, uh, the methods of attack are more easily available to attackers. There's more resources, there's fantastic tools that can enable and facilitate adversaries with ill intent, particularly with APIs. So APIs, while they have obviously been very successful in transforming digital business, one of the challenges with APIs is because they are, by their very nature, they open and they public, they lend themselves to being abused easily. And I think just a data point would be, I don't have the figures to hand from the latest whatever reports, but typically somewhere around 80% or more of internet traffic is now consisting of API traffic, which is a pretty staggering statistic. And I think more and more attackers are not bothering to attack the web application and understand the intricacies of how the web application is behaving, but they would rather just go to the GC bits, which is the back end, and depending on that, and attack that API. So APIs are, we've got good tools. The APIs are visible. There's very good techniques for attacking APIs, and because APIs don't require the kind of user interaction that you would with a web app, they suited to automated attacks, and that's where we see these attacks. So that we have that feature in that newsletter where we see mass scale scraping of data. So, for instance, Twitter, they exfiltrated, or they had all of their user email and phone number data exfiltrated of all their users. That's hundreds of millions of records. Right, and we see these mass, what I call, these large volume API attacks, where companies are losing all of their, not some of their data, they lose all of their data, and even more worrying, they're unaware that these attacks have happened because the attackers are exfiltrating over a long period of time and are flying under the radar of detection. So that's the very pessimistic scenario that I think the problem is going to get worse. I think APIs are the sweet spot. Those APIs are going to carry on proliferating, and we still have the legacy problem where we have pre-existing APIs that are not secured. And then also with with APIs, a lot of the problem as well is inventory or a lack of inventory. So people don't know what they have deployed. The recent Optus breach in Australia. That was Optus is a Australian telco, and they had an API that was meant to be internal only. They accidentally somewhere along the line made that public, and they didn't note that they'd done this, so they had a publicly exposed API, and again they lost all of their customer data. So that's the pessimistic view, and I think it is pretty pessimistic. Um, and and now, well, I mean, and there's another issue as well that I think is concerning from the pessimist point of view is that we've got great resources. Hopefully, my book is now one of those helpful and useful resources that is teaching people the basic of API security, like understanding the OWASP API top 10 security and learning the patterns and best practices. The real danger and real concern for me is even with the most perfectly implemented API. So if you had something that was perfectly secure, that API can still be vulnerable to abuse and misuse. So I'll give you an example. An API, the Twitter API is a breach is a very, very good example. So Twitter enabled an API that allowed the client, the Android client, to be able to check if a username existed or not. So when you go and log in, it tries to prompt you a reminder of your username. But an attacker worked out that, well, they could abuse that, and they wrote a scraper that just scraped that and then was able to pull all the usernames out of Twitter. And they did that over 18 months. So that's an example of an API that's not actually vulnerable. There wasn't a flaw in that API. There wasn't something you could have tested and found. That was a business logic problem. That was a design problem. And then the other major issue that we see, and I can count a dozen or more of these that have happened in the last 7 or 8 months, API key and token leakage. So organizations are being infiltrated and they are using keys and tokens of third parties. So it's a supply chain attack where third parties are losing all of the tokens that they have to access other systems. So clever attackers are compromising cloud services and then gaining access to GitHub repositories and stealing source code out of GitHub repos, for example. And they're all doing that via API tokens. So again, nothing wrong with the API, but what the mistake that people have made is they are losing the keys. It's like having an incredibly secure house with 5-lever mortise locks and the rest, with latches and locks on every window. But if you lose your keys, right, your house is no longer secure. So that's the analogy. So longer than I would have thought there, the pessimist view. So let's try and cheer everybody up, and oh, yeah, yeah. Let's get the optimistic view. So so things I like about API security and where I see things changing is the enormous interest and the fact that Packt have gone and published a book on this or have books on the topic in the works. There's a lot of fantastic resources. So there's newsletters, there's a number of learning resources. If people want to get involved, if developers want to get involved in API security, I'm working for 2 or 3 different customers at the moment. For each one of them, I'm delivering internal training content on API security. So it's a very hot topic. People are learning, are keen to learn and keen to understand the problem better. I think from a technical point of view, what I like about API security from a perspective relative to web application security. So web application security is a pretty unbounded space. So your threat landscape is enormous. You've got different ways of attacking web pages. You've got different behaviors on web pages. You've got a number of different attack vectors that can be leveraged against those web pages. Right now, that means that your attack surface that you've got to defend is enormous. So, from a defense point of view, it's a real challenge. Now, APIs, the advantage they have a far more bounded perimeter. Right, the APIs have a contract. The APIs are meant to do a specific thing according to a contract and no more. So if you develop your APIs correctly and you use contract-based API development, where you specify how that API should behave, it then becomes an easier problem to ensure that the API does only what it is supposed to do and doesn't misbehave, right? And you can test this. So you can test this at every stage of the software development life cycle. You can test it in your own IDE as you write in code. You don't have to wait until you've built your entire web application and then run your pen test just before you ship to production. As an API developer, you can test instantly. You write that code immediately. So you've got much better testing because the testing can also be far more precise because it's not trying to manipulate and misoperate web pages. It's actually just working directly with using the contract, operating that API and working out what that API is doing. So one thing there, the testing is a lot better and can be done throughout the life cycle. And then the other big point is that because you have a contract, because you have known behaviors, you can defend against that. So you can use a lot of great technology that we have now. So web application firewalls and API gateways are becoming aware of API contracts and they can enforce that contract. So what that means is, take an example, an API that is accidentally leaking customer PRI data. At the gateway, you can capture that. You can see, well, there's something that looks like a telephone number. That API is not supposed to be leaking that, so I will block that at the API at the gateway level. So that the technologies that can protect APIs are more precise and can be more accurately enforced than than the more nebulous sort of web application firewalls, which are trying to block what they think is it's basically from a technical point of view. A positive security model versus a negative security model. A negative security model tries to guess everything that's bad and then block that. Positive security model only allows the good things or what is known. And that's a much smaller set than all of the known bad. If I asked you to give me all of the invalid data that you could submit to a web application, that's an impossible task, right? Because you could character encode it, you could submit it in different languages, you could use different character sets. It's an unbounded problem. Whereas with an API with a contract, you can specify the exact form of that data that you're processing. So that's the optimist view. Is I think smaller boundary, smaller attack surface, and the contract development life basis because you have you know what your data is and you can protect and guard against that.
Given the massive rise in API usage, it is no surprise that the risks associated with exposed APIs have increased. What are some common knowledge facts, misunderstandings, or misconceptions that are causing gaps in an enterprise's API security strategy?
So examples of things that we see. So I mean, if we just go down and probably the way to pick this off, and I'll try and give you some illustrative examples of the OWASP API top 10. So by far and away, the most common vulnerability that we see is still broken authentication. I would say it's not top; it's second. It's the second most common vulnerability according to OWASP. Um, Authentication, people forget to authenticate APIs. They'll write an API, and they just don't implement authentication at all. Or where they do implement it, it's broken. It relies on, for example, basic authentication, where it's quite easy to be able to brute force attack that API. You can get password lists, and you can just brute force that. So weak password policies. Often the authentication is misimplemented. So from the ridiculous, and we have had examples of APIs that have taken a password but have allowed a blank password, right? So the attacker has just said, right, I'm not submitting it, just send a username and no password, and the API accepts that. Right, so completely broken authentication. We've got various permissioning problems. So this is on the authorization side. So just to disambiguate here, authentication is who you are, right? And that's basically logon credentials. Authorization is the bigger problem for APIs, and that is what are you allowed to do. And then typically here we've got two different categories. We've got APIs that allow you to access data that you shouldn't be allowed to access, And you've got APIs that allow you to do things that you shouldn't be allowed to do. Both are dangerous. So, for example, the latter, we've seen API endpoints that have a delete operation that allow you to delete your, let's say, collection of photographs. And we've discovered that people are able to use that API to delete other people's photographs by just manipulating identifiers. Those are the more severe ones. Those are also, fortunately, the ones that are actually relatively easy to fix. Challenging, well, the more challenging category are around data. Remember, APIs are all about data, and they're the conduit to connect and transport your data. By far, the biggest problem is around APIs is the fact that your attackers are essentially they're trying to do two things. They're either trying to cause your APIs to misoperate and do things that they shouldn't do. So think about attacking systems where they're wanting to launch a denial of service attack and they're wanting to take a system out of commission. But most often, they're trying to steal the data. And often, APIs will typically, and I'll explain the reason for this, APIs can be too chatty. They can return more data than they're supposed to, and this is unfortunately a downside or just an artifact of human nature. So when a developer is building an API and they're trying to decide what data they should return, they don't always have a clearly defined use case. They don't fully understand the consumer's requirements. So, an example in the newsletter from about a year or so ago, there was a UK-based courier company that allowed you to, on the API, you could enter a tracking number. And this is a good example of an API vulnerability in detail. They allowed you to enter a tracking number, and then if you gave them a correct tracking number, they gave you a little map view of where your parcel was. The attacker worked out that they could take the map view and get the postcode, because we know in the UK, if you know a couple of street names, you can reverse engineer the postcode. So they got the postcode. They used another API to take that postcode and the tracking number, and then it dumped a whole load of PI information, which included the recipient's full name, date of birth, phone number, email address, etc., plus the time of delivery of their parcel. So that's a great example of quite a few things going wrong with APIs there. So let's disassemble that and pull that to pieces. So the first problem was that there was an API endpoint that took a parcel number. And the assumption was, presumably in the developer's mind when they wrote that, was people wouldn't know the parcel number. But of course, a parcel number is guessable. It's got a standard format, a standard length, a standard character set. So it was easy to guess those. Now, the the classic way to protect against that is to stop an attacker being able to iterate through that API and call in quick succession to be able to call that API. Because what the attacker is doing is essentially having to do a dictionary attack where they cycle through all of the possible password numbers. Now, the standard way to protect that is you rate limit on that API endpoint. So you put a timer on that. And if you see that you're getting lots of successive requests from the same IP address or the same client, then you back it off and you put in a delay. And that has the effect of, I mean, you must have seen this when you log into a bank. If you get your password wrong 3 times, it locks you out for a minute or more. And that's to stop an attacker being able to brute force that endpoint. So firstly, that API had no brute force protection, so they're able to iterate through that. Secondly, they returned a map which they thought was safe, but they didn't realize that obviously in the hands of an attacker, it's very easy to then get a postcode. And then the fact that you had now two pieces of information could identify you to that API, and the API should have returned just the ETA, the delivery time slot for the parcel, but instead it dumped all of the PII data, right? And then the problem there was that the developer didn't know who was going to be consuming that API and thought they would be helpful and just return all the data that they had rather than the minimum amount of data that was needed, right? So that's an important point to disambiguate. Don't return all of your data, just return the bare minimum. Right, and that was data leakage. Now we see that all over the place. Nearly all APIs that have leaked data have done that type of pattern where they've returned more data than they should. So that's your top API vulnerability, and normally the APIs will have one or other of those problems: lack of rate limiting, broken authentication. Um, that can be combined to leak data. And then we have another couple of obscure ones, which I'm not going to go into a lot of detail there, but are more the classic AppSec things like injection attacks, where you can manipulate the backend database, misconfiguration, where servers accept data that they shouldn't, and then people can break the API with it. APIs that are misconfigured and are public, and they should be private, etc. But those are the sort of less interesting ones. But generally, it's about the data. And we see various ways that APIs leak too much data.
There is an ecosystem around APIs. There are teams that create APIs, others that manage and architect them, etc. With so many teams and roles involved in API development and usage, where does the ownership lie for API security?
Yes, that's a great question, because that is one of the problems with API security, as far as I can see it, because that's where things fall through the cracks. So let me just give you approximate rundown. I'm just going to use an anonymous example of the company that I'm working for at the moment. So there they have a product team who are the team responsible for producing the API. They have a platform team, which is the team running their Apogee instance. Apogee is an API gateway. So think of that as your cloud platform that hosts the APIs. They have a data protection team who's responsible for data. They have a DevSecOps team who's responsible for running their SAST and DAST in the pipeline. They also have a product engineering or product security team who's responsible for the end-to-end product security. And then they have various AppSec consultants involved. So, and then they also have an IDM, identity and access management team, who's responsible for managing the identity within that organization. So there you've got, well, I can count those, but you've got at least 6 or 7 different stakeholders, right? And it's very hard there to have a joined up view on how their APIs are being secured. Because if, for instance, if they're producing API backend code that is vulnerable, so let's say their code has flaws and vulnerabilities, then that API isn't going to be secure. So they need to be doing static analysis and checking that their code is good. The QA and test team, there's another team we didn't mention, and that they need to be doing, as part of their conformance and acceptance tests and their regression testing and the like. They also need to have API security testing as part of their suite, right? And if that's missing, you're gonna have faulty code that's going into production. If your Apogee team is not implementing any kind of rate limiting, or not validating authentication correctly, then you're going to have gaps there. If your data team aren't telling the development teams what will the provenance of that data, and which data should be protected and which should be available, then you can have data leakage issues. So you can see that's quite a good and a very real world. I mean, I'm literally working in that at the moment, and that's typical of the problem that you have. So while I'd said that APIs are a relatively bounded problem, you also have a lot of there's a lot of chefs in the API kitchen. And it's so who would hold the ultimate responsibility there? I mean, we would know that essentially it would go up to the platform or the product owner, but obviously they're a long way removed from the day-to-day operation. Um, so I think what's important there is to delineate the roles and responsibilities. So, for instance, the identity and access management team, they provide identity. They should ensure that the access control is rigid, that each person only has authorization to access what they should and shouldn't access things they shouldn't. The Apogee team, we should down their scope and say, you're responsible for X, Y, Z, and divide and conquer there. But it's getting that. So I think the problem with that is each of those teams are individually excellent at their own roles. They understand what they do, But a lack of joined up thinking is kind of where these what lets these bigger organizations down, right? Is they don't have that big picture of the end to end of really understanding what can go wrong with an API and how an API can be abused. But that is a solvable problem. Is it API specific? It is to the extent that APIs appear in places that they norm other pieces of technology wouldn't. So let's just say in the old days, if we built a typical three-tier front end processor and then database backend, we would have a normal three-tier architecture. Everything would be integrated, and all that we'd see when that thing goes to production is a platform that launches, and nobody's aware of those inner workings. But of course, now with the advent of microservices and distributed systems and third-party providers and cloud compute and now AI, we've got all of these disparate and heterogeneous systems that are now needing to be connected, and APIs end up being visible, right? And they're the point of easy access. That's where everything manifests. That's where and because of their universal connectivity, that they get exposed, they become the point that everybody can see and can focus on. So, I mean, there's nothing peculiar about them other than they are just the most visible artifact of modern software systems.
What are the core pillars of API security? And what do you mean by the term continuous API security?
So the idea of being continuous is, I mean, it's very much driven by the shift left movement, which is, moving security as a consideration. I'm not even going to define any of those individual pillars, but thinking about security as early as possible in the life cycle. I'm sure your listeners are very familiar with shift left. I won't go into the philosophy behind that, but the anti pattern would always be shipping a piece of software, and there's still examples. I still see organizations now that don't do any security design, they don't do any threat modeling, they don't do any architecture, they don't do any secure design practice, they don't do any secure development practice, they don't do any testing. They will build and ship an entire product, and then they will do a pen test on it, right, to see if it's got any vulnerabilities. And of course, there will be, and now you've got to decide, are you going to stop the release and go back and fix all of those. So w- let's come back and again, pessimist, optimist. So the reason that shift left has been troublesome to being has had problems being adopted widely as a practice is the fact that your big applications, your monoliths, your mobile applications, oftentimes, it's only feasible to test that when you've actually got a candidate release. You've got something that's been built and working, and often that can only happen either infrequently or relatively late in the process. So if you're doing a big, large scale integration, you've got to have a lot of things working together before you can build something that is actually testable. Now, APIs change that whole dynamic because I mean, I could sit literally while we're sitting on this podcast, I could sit and write an API and run it and test it for you in minutes, in minutes, not in a few minutes, not even tens of minutes, not even an hour or more. Because the APIs, their time to build a viable candidate, to take a concept, to take an idea. Let's say we wanted to make an API that could create a user, update a user, read a user, and delete a user, right? Standard CRUD operations. I could write that in Python and I could have that running in a minute or less. And at that point, because I've got a contract, I could then test that API as well, right? So, and that's what the beauty of the continuous aspect is that from the very moment that that API first runs, I can test it in Postman or some other tool and see, yes, it's functioning correctly. But I can also have behind the scenes, I can have API testing that is running. And what that is doing is it's testing each of those endpoints and seeing that they behave as they do. So, for example, that delete operation, it will call that delete operation, and it'll give it my identifier and see that my object gets deleted, but it'll also give it somebody else's identifier and see what happens, because that object should not be deleted, right? And then that's how that continuous testing works. And that gives the developer a much higher degree of confidence that the API is functioning as intended. Coming further down the life cycle, that same testing can be implemented in a pull request and a merge request. So every time the project lead or the technical lead has to merge in pull requests, they can have that same level of testing running and verify that those changes aren't breaking. They're not going to break anything. And then, of course, as you start assembling these more complex systems, you can continually do end-to-end testing of those systems against those contracts.